Hey everyone, welcome in. Today we're fortifying our defenses and venturing into the world of Docker and cybersecurity. Specifically, how Docker, a tool developers use every day, can actually make applications more secure.
It's a fascinating intersection, isn't it? We often think about security as uh, this separate layer on top of our applications, but Docker really challenges that whole notion.
Okay, so for those new to the fortress, as we're calling it, that is Docker,
hmm
how would you quickly break down what it is?
Okay, so imagine this. Instead of building your application directly on a server, you package it into this neat, self-contained unit. It's called a container. This container, think of it like a mini computer within your computer, includes everything your app needs to run. I'm talking the code, the libraries, all those dependencies, everything. And it's all sealed off in its own little world.
So each container is like what, a studio apartment for your app? Like it has everything it needs to function without relying on its natures.
Yeah.
And this containerization thing, this is a big deal for security, right?
Absolutely. Think about like a traditional server environment. You have one vulnerability, one single crack in the armor, and boom, an attacker could potentially access everything on that server. It's like living in a house with no interior walls. But with Docker, each application component is living in its own isolated container, its own, fortified room. This is what's so great about Docker's isolation. Like, it's one of its biggest security advantages.
Okay, so going back to the house analogy, if someone breaks into one room, they can't automatically get into the rest of the house. The damage is limited.
Exactly. Take the infamous Equifax breach back in 2017. A vulnerability in a web application component allowed attackers to access millions of customer records. Millions. Had Equifax used a containerized architecture, something like Docker, the impact of that breach could have been, well, significantly contained. The compromised component would have been isolated, which would prevent attackers from easily moving laterally to other parts of the system where, sensitive data resided.
Wow, that paints a very vivid picture of how disastrous things can be without these security precautions. It makes you wonder why every company isn't adopting these strategies.
Well, like any security approach, it has its complexities. But the core concept here, this idea of isolation, it's foundational to having a strong security posture. And Docker just makes it much more, well, elegant and practical to implement.
Okay, so Docker helps us lock down each part of our application with isolation. What else does it bring to the table in terms of security?
Consistency is another major one. With Docker, you create an image of your application, kind of like taking a snapshot of its ideal state, right? This image is then used to create, identical containers. This ensures your app runs the exact same way every single time.
So if someone tries to sneak in some sort of code change or like tamper with the configuration, Docker's going to notice because it'll be different from that original snapshot.
Precisely. This immutability, this fact that these images are designed not to change, it's crucial for maintaining a secure environment. Hackers often try to exploit vulnerabilities by like injecting malicious code or altering configurations, right? Docker's consistency makes these tactics much harder to pull off. It's like having a security camera constantly comparing everything to the original blueprint.
Okay, so we've got these secure containers, each one a fortress unto itself, all based on these unchanging blueprints. This already feels like a huge win for security.
It is. And this leads us to another major advantage. We call it a reduced attack surface. Because Docker containers only run what's absolutely necessary for your application, you're essentially minimizing the number of potential entry points for attackers.
Fewer doors and windows for those metaphorical intruders to try, right?
Hmm.
So instead of defending a sprawling castle with multiple entrances, we're down to a more manageable fortress.
Exactly. It ties into the fundamental security principle of minimizing vulnerabilities, right? The fewer things you have to secure, the better. It's about building secure systems from the ground up rather than trying to patch holes later.
This is all making a ton of sense. Docker creates these secure, isolated compartments for your app, making it much harder for attackers to infiltrate and exploit vulnerabilities. But it's not just about isolation, right? What else makes Docker such a powerhouse when it comes to security?
You're right. It's more nuanced than just building, digital fortresses. The way Docker allows you to control access to resources, break down apps into more secure segments, and even integrate with powerful external security tools. These are all critical parts of the story.
Let's dig into that then. We'll uncover these additional layers of the Docker security story right after this.
And we're back, delving deeper into this fascinating world of Docker and how it's reshaping the cybersecurity landscape. Before we went away, we were talking about isolation and minimizing, the attack surface, essentially building stronger walls around our applications. Yes, and like any good fortress, Docker doesn't just rely on thick walls. It implements, robust access control mechanisms to further secure its interior.
Okay, so walk us through this. How does Docker function as that vigilant guard, controlling who gets in and what they can access?
Think of it this way. In a traditional server setup, applications often have broad access to system resources. We're talking the network, the file system, even the kernel itself. It's like giving everyone in a castle a master key, even if they only need access to one room.
That sounds risky.
It is. But with Docker, you can specify exactly which resources each container is allowed to access. So does your web server need to communicate with the internet? Okay, grant it network access, but nothing else. Does your database need to write to a specific directory? Fine. Define that permission explicitly. Everything else is, by default, locked down.
So it's like each container gets its own carefully curated set of permissions, a key card that only unlocks the doors they absolutely need. This principle of least privilege, this is a cornerstone of good security.
Absolutely. By limiting access to only what's essential, you drastically reduce the potential damage an attacker could cause, if they were to breach a container. It's about containing threats, minimizing their blast radius.
This, granular level of control is impressive, but our sources also hinted at Docker's ability to break down applications into smaller, more secure segments. How does that work?
That's where microservices come into play. Imagine instead of building one, massive application, you break it down into smaller, independent services, right? Each service handles a specific function, like processing payments or sending emails or maybe managing user accounts.
So instead of a single giant castle, we're talking about a network of smaller interconnected fortresses.
Precisely. And Docker is fantastic for deploying and managing these microservices. Each service gets its own container, its own isolated environment. Now, if one service is compromised, well, the impact is limited to that service alone.
Right, because the other services are locked away in their own, fortified compartments. They're not automatically vulnerable just because one part of the system was breached.
Exactly. This approach, it's often called segmentation. It's like having bulkheads in a ship. If one compartment floods, the others remain sealed, which prevents the whole ship from sinking. And Docker makes implementing this kind of segmentation, surprisingly straightforward.
Okay, this is really driving home the importance of compartmentalization and controlled access. But there's more to Docker's security prowess, isn't there? What about these other tools it can integrate with?
You're on the right track. Docker, by design, plays well with other really powerful security solutions. Think of them as adding state-of-the-art security systems on top of our already fortified Docker containers.
Okay, I'm intrigued. Give us the rundown on some of these security add-ons. What are we talking about here?
Let's start with SecOps, short for Secure Computing Mode. Remember how we talked about Docker controlling access to resources like the network and file system? Well, SecOps takes that control a step further by restricting the types of actions a container can even request from the operating system's kernel.
The kernel, that's the heart of the operating system, right? The core that everything else relies on.
Exactly. And while Docker does provide some basic controls, SecOps allows for much more, let's say, fine-grained restrictions on how containers interact with the kernel. It's like having a security detail that intercepts every request a container makes and checks it against a very strict set of rules. If something seems even slightly off, the request is denied.
So even if an attacker managed to breach a container, SecOps would act as that final layer of defense, preventing them from doing anything truly malicious at the system level.
Precisely. And then there's AppArmor and Linux, which take access control to an even higher level. These tools enforce what's known as mandatory access control, which goes beyond even what Docker itself provides.
Okay, break that down for me. How do AppArmor and Linux differ from what we've already discussed?
Imagine this. Docker lets you define access rules for resources like files and directories, right? But with AppArmor and Linux, you can create incredibly specific rules that govern virtually every action a container can perform. I'm talking about reading files, writing data, making network connections, you name it.
So it's like having a detailed rulebook for every single action a container might attempt, ensuring that nothing falls outside the bounds of what's allowed.
You've got it. And these rules are enforced at the operating system level, meaning even if an attacker gains access to a container, they'll still be bound by these very strict limitations. It's like having a security system that monitors not just who enters a room, but what they do once they're inside.
This is all incredibly impressive. Docker, with its isolation, access controls, and ability to integrate with tools like SecComp, Aparmer, and Linux, really does paint a picture of a truly secure environment for running applications.
It certainly provides a robust framework for building secure systems, but it's important to remember that no technology is foolproof.
Right, there's always a catch. What are some of the potential risks or vulnerabilities that we need to be aware of when it comes to Docker security?
Well, for starters, even with the most secure technologies, human error can still creep in. Misconfigurations are a common pitfall.
Okay, let's unpack that. What are some examples of misconfigurations in the context of Docker, and why are they such a big deal?
One classic example is running containers with root privileges.
Now, for those of us who aren't deep in the technical weeds, what exactly does that mean? Root privileges, and why is it a security no-no?
Imagine the root user as the king of the castle. They hold the master key to everything, right? Granting a container root privileges is like giving someone inside that container the king's authority. They can do pretty much anything within that container's environment.
And if an attacker breaches that container?
They inherit those root privileges. Suddenly, what might have been a minor intrusion becomes a major security breach. Instead of being trapped in a single room, they now have the keys to the entire castle.
That's a stark reminder that even with all the security features Docker provides, we still need to be incredibly diligent about how we use them.
Absolutely. It's like having the most sophisticated security system in the world, but leaving the front door wide open. You're only as secure as your weakest link.
So, misconfigurations, especially around things like user privileges, are a critical consideration. What else should we be keeping in mind as we navigate the world of Docker security?
Well, we've talked a lot about the isolation Docker provides, but it's essential to remember that containers still share the host operating system's kernel.
Right, it's like all those separate apartments within the same building. They might have their own secure entrances, but they all rely on that same foundation.
Exactly. Now, if there's a vulnerability in that shared kernel, like a crack in the building's foundation, it could potentially impact all the containers running on that system.
So even with all those fortified walls and security systems, a weakness in the underlying system can undermine everything.
That's why it's absolutely crucial to keep your host system updated and patched. Regularly applying security updates is like reinforcing that foundation, ensuring that the entire structure remains secure.
It's like a constant game of cat and mouse, isn't it? As security professionals develop more sophisticated defenses like Docker, attackers are always looking for new ways to exploit those systems.
That's the nature of cybersecurity.
Mm.
But there's one more potential risk area I want to highlight before we wrap up our discussion on Docker: image vulnerabilities.
Right, we touched on this earlier. Docker images are those blueprints for our containers, right?
Exactly. You use images to create consistent, reproducible containers. But what happens if that blueprint itself contains vulnerabilities or even malicious code?
Okay, that sounds like a serious problem. How do these image vulnerabilities even happen? Aren't these images supposed to be secure?
Ideally, yes. But remember, Docker images are often built on top of other software components, libraries, and dependencies. And any one of those components could contain vulnerabilities. It's like building a house with materials that have hidden flaws.
So even if we're diligent about configuring Docker securely, we could still be introducing vulnerabilities right from the start by using a, compromised or outdated image.
That's the risk. And it highlights the importance of using trusted sources for your Docker images.
Like official repositories or well-established vendors.
Exactly. And just like with any software, keeping your Docker images updated is crucial. Don't just pull an image once and forget about it. New vulnerabilities are discovered all the time, so staying up to date with the latest security patches is essential.
This is a lot to digest. We've covered so much ground, from the core principles of Docker security to some of the potential pitfalls. Before we move on, let's take a moment to recap the key takeaways for our listeners. Okay, so to quickly recap where we've been in our exploration of Docker and cybersecurity, Docker provides this powerful framework for building more secure applications. And it does this by isolating components, controlling access to resources, and enabling a more secure architecture with microservices. It's like we're not just building a stronger house, but rethinking the entire neighborhood for maximum security.
A great analogy. And remember, we can further bolster Docker security by integrating tools like, remember, SecComp, Aparmer,
Yeah.
and Linux. They act as those specialized security details, monitoring and restricting actions with, incredible precision.
Right, like having a security guard at every door and a watchful eye on every activity within our fortress. But, as we've discovered, even the most sophisticated fortress can be vulnerable.
Precisely. We talked about the risks of misconfigurations, like accidentally leaving the keys in the ignition by granting excessive privileges. And we can't forget about the importance of a solid foundation, that shared operating system kernel, that, if compromised, can undermine even the most secure Docker setup.
It's a good reminder that security is not just about the tools themselves, right?
Yeah,
But how we use them. Diligence, best practices, constant vigilance. These are essential, no matter how secure the technology promises to be.
absolutely. And that vigilance extends to the very building blocks of our Docker deployments. Those images we use to create containers. Using a vulnerable or compromised image is like building our fortress on a foundation of sand.
So, to wrap this all up for our listeners, what are the most critical takeaways here? Those essential things to keep in mind as they, explore the world of Docker and its role in fortifying their applications.
First and foremost, Docker is a powerful ally in the fight for more secure applications. It provides a framework, a set of tools that, when used correctly, can significantly enhance your security posture. But, and this is important, it's not a magic bullet. Understanding the potential risks like misconfigurations, shared kernel vulnerabilities, image vulnerabilities, this is crucial.
Right, it's about being proactive, not reactive. Don't wait for a security breach to realize you left the back door open.
Exactly. Embrace the security benefits Docker offers, but, remain vigilant. Keep your host system updated, choose your images carefully, and follow security best practices every step of the way.
It sounds like, in many ways, the security principles that apply to, any software development project, they're even more crucial when working with Docker.
You've hit the nail on the head. Docker doesn't change the fundamentals of good security hygiene. If anything, it amplifies their importance.
And that brings us to the question we love to leave our listeners pondering. As more and more organizations adopt Docker, as containerization becomes the norm, how do you envision the threat landscape evolving?
That's the million-dollar question. Will attackers develop highly specialized exploits targeting Docker itself? Will we see a resurgence of attacks aimed at the underlying, operating system layer? Or will the focus shift to exploiting misconfigurations and human error, the weakest link in any security chain?
It's both fascinating and a bit daunting to think about. One thing's for sure, the world of cybersecurity never stands still. As technology advances, so too do the threats we face.
And that's what makes this field so dynamic and constantly engaging. We need to stay informed, stay curious, and always be ready to adapt our defenses as new challenges emerge.
Well said. A huge thank you to everyone for joining us on this deep dive into the world of Docker and cybersecurity. We hope you've gained some valuable insights and perhaps even a renewed appreciation for the ever-evolving nature of building secure systems. Until next time, stay curious and stay secure.